In this video, I'll be fine-tuning Gemma 2 in 5 simple steps. So the steps will be broken down into 5 steps. We can download the model and data. We're going to do basic inference, prepare the dataset, train the model using 2 different options, and we're going to save the model at the end. When it comes to preparing the dataset has to be prepared in a specific way with tokens in the beginning and at the end of a sentence. Now we're going to go into details on how it exactly works. Now, let's crack on with it. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools, so please feel free to subscribe. So the first thing that we're going to do is we're going to install the packages that are listed over here. So we have bits and bytes, PEFT, TRL, accelerate, dataset, and of course, transformers. Now you will need the latest transformers version, if in case you guys are wondering. And we're using a A100 GPU with a 40GB VRAM, and these are the different versions that you will need. Now, after we import our torch and transformers, we're going to set up our bits and bytes config, and then you may need to log into Huggingface Hub because some models may require you to have authorization. In my case, I have the HF token embedded into my environment, so I don't have to worry about that. And if I'm not wrong, I think Gemma 2 doesn't actually require authorization, but anyhow, now we get to load our model. So we can define the model ID, which is in this case, Gemma 29 billion. You can also use Gemma 27 billion if you have the GPU power, and then we're going to load the model with the BNB config device map and the model ID that we defined. Now let's load it. As promised, I will show you guys how to make a very basic inference. So to do that, we're going to define a nice function called getCompletion, where we define a prompt template. And this is the template structure that I was discussing earlier. We have the prefix and the suffix, and then the prefix again for the model to start generating. We pass in the prompt, we encode it using the prompt with the query, and then we encode it so the model can understand what we've asked, and then we start decoding it. So if we quickly print out the results, and now we have a response on how to get the Fibonacci series in Python using recursion. And as you can probably see, it's not really giving us a really good answer. And after fine-tuning, this should be solved. Now to do that, we're going to load a dataset. So the dataset that we want to load will look like this. We have an instruction, input, and the output. So we're going to load the dataset. Code instruction, alpaca style, split train. Now, if you inspect the data, we have the text, we have the output, and the instructions. Now, one thing to notice is that it's not really formatted the way we want it to. So we have to fix that before we start feeding into the model. Now, to do that, we have a special function for that. We will write generate prompt. We're going to pass in the start of turn and end of turn so the model can understand and start to generate. And then we're going to modify the data by calling the function. And we will also shuffle the training data and tokenize the prompt. I know it's a lot of steps that we're going through here, but please bear with me. Now we're going to get the training and test data. And after that, if we print the test data over here, just to see how it looks like, we have input, text, instruction, output, prompt, input IDs, and then we have the attention masks. Now we're going to apply LoRa into our model. So we're going to from PEFT, import LoRa config and other LoRa stuff. And what it's essentially going to do is, or the reason why we're doing this is because we want to only fine-tune small number of parameters. We're going to define a function, find all linear names, and then we're going to add the linear names to the LoRa config. At the end, we can get a nice statistics. What is the percentage of parameters that will be trained? Now, let's actually do the training. So first off, I'm going to show you guys, or give you guys the code on how to train it with Transformers Trainer. Now, I'm not going to execute this, but I just want to mention that you can use Transformer Trainer. We pass in the train data, evaluation data, and the different training arguments like warm-up steps, max steps, learning rate, and so forth. These are something that you want to play around with to get a better performance. By the way, I want to quickly mention about Data Society. Data Society is a private community where you can access highly advanced guides on boosting performance for your LLM application. We have continued pre-training, advanced RAG techniques, deployments using different strategies. Not only that, once you join, you also get access to a community, calendars for booking one-to-one meetings with me. You also get updates on different topics that come up in AI every week. So please feel free to join. Now, we want to use QLoRa and supervised training to train our model. And to do that, we're going to import transformers again, import TRL, import SFTT trainer. From the tokenizer, we get the EOS token, and the trainer looks exactly similar to the previous steps we have over here. So very, very similar. Again, these are parameters that you may want to play with to get a better output. Now, once we define that, let's actually start training. So we're going to put the trainer.train, and then we just simply wait until it's finished. Now the training has been finished. Now we can actually save the model. So we're going to name this Gemma to code instruct fine tune test. And then we can save the model where it's going to merge all the different weights. Now we get to load the model that we've saved in our local directory. We're going to first load the base model, load the merged PEFT model, and now we're going to save it. Now we get to test our model. But before we do that, I just want to quickly show you guys how to save and push the model to Huggingface Hub. Now, if you guys remember, we actually tried to log in to Huggingface Hub over here. And one other reason for that is actually to push it to the Huggingface Hub. That is the best way, in my opinion, to save a really large language model for no money. So in this case, I'm not going to push the model because I don't really need to. But all you guys really have to do is uncomment this code and just push it. And you're good to go. So now let's test the model that we have trained and see if it actually gives the output that we want. So over here, we ask the same question, the same query. We pass in the merged model that we just trained and the tokenizer. And now we print out the results. And here we go. Here we can see we get a much better response right now after we fine-tuned it when we ask a query like code the Fibonacci series in Python using recursion. Alright guys, I hope you guys found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. And by the way, please check out the Data Society page for accessing highly detailed and advanced guides on further pre-training a model with unlabeled data and other deployment tricks. Alright guys, I hope to see you in my next video. Have a nice day.